Hi everyone, today's lesson is on circles. It's a chapter 9 test review. So let's practice with a few problems for our test. Get us ready. So getting started, we're going to use circle T for problems 1 and 2. So we're going to name an arc that has a measure of 230 degrees. So before we do that, we need to fill in the rest of the circle arcs. So we have this being 40 degrees, this central angle. If that's 40 degrees, so is that. That's 40. If this is 50, this is also 50 degrees. We do recognize that this angle and this angle are vertical angles, so those are 50, which makes that 50. And halfway around the circle, which goes from here to here, we call that a semicircle, remember? That's 50 plus 40, which is 90, which would make that 90 degrees here. And if this is also a 180 degrees and that's 50, that would make this 130 degrees. So our job is to find an arc that has a measure of 230 degrees. So it would be 130 plus 100. So I'm thinking we're going to go from B all the way to D. So you're either going to say arc BAD. So you can say arc BAD. I could also say arc BED. Okay, arc BED. And there's, of course, there's a couple of ways to say that, but those are two ways I could say that. Find the measure of arc DE. So DE being right from here to here. Well, that measure of that arc is just 50 degrees. Suppose a chord of a circle is 18 inches long. So let's say, here's my chord, and that's 18. It is 40 inches from the center. So that means that here's my center. It's going to be 40 inches from that. And that means that that's now 9, because if it's from the center, it is perpendicular and bisected. Find the length of the radius. Well, for this problem here, all we have to do is use Pythagorean theorem. If this is the right angle right here, that means this is my hypotenuse. We're going to call that x. So we would just go 9 squared plus 40 squared is equal to x squared. 40 squared, which is 1600, plus 81 is going to be 1681. Is equal to x squared. And then when you square root both sides, you get x equals 41. Okay. Use this given circle, and your job is to find arc BC, the measure of ADB, which is this arc here, and also arc BAD, arc BAD. So starting here and going all the way around to here. Now, a couple of things. Remember our inscribed angles. If this angle here is 45 and this one goes like this, goes all the way out, arc, keep going here and here, then that means that's doubled. So that's a 90 degree. And if, let's see what we know. We also know, I'm going to erase some of this stuff in here. I also know that this angle here, 40 to 50, this angle here, it's a quadrilateral inscribed in a circle, and that means that all my vertices are touching. So that means that opposite angles are supplementary. So that means that this is 50 plus 45 is 95. Excuse me. So 50 plus 45 is 95. So 180 subtract 95, borrow. And so we have 5 and 8. So this is 85 degrees here. If that's 85 degrees here, okay, that means this arc from here to here, okay, is double that. So that's going to be 170 degrees. So 85 times 2, 0, 1, 6, 170, is this arc from here to here. Well, I want the arc from BAD. So I want this arc going around the other way. So therefore, I'm going to take 360 degrees and I'm going to subtract 170 degrees and I'm going to get 190 degrees. So BAD, arc BAD is 190 degrees. ADB is our next arc. I want this one right here. Okay, that's the next one I want right here. But in addition to that, let's see what else we know. Let's see, BC, where's BC? This arc here. Okay, so we can find that one right now because BC being this arc right here. Okay, so if that's 27, then that's double. So this here is double. So we're going to take 27 and times that by 2. So that's 4, 1, 4 plus 1 is 54. So this arc here is 54. Keep in mind that from B all the way down here to D, B, C, D is 170. So I can find what this arc is right here, okay, by just subtracting 170, let's see, minus 54. And that makes, let's see here, that makes, borrow 8, 7, 6, and that's 96. So that means that that's 54, that's 27, let's see here. 96 is the leftover here, so 96, which means this arc here is half of that. So if I take 96 and I divide by 2, I'm going to get 48, and so this is 48 here. And what I'm looking at also, I know there's a lot of stuff going on, so I'm going to try to get rid of some of this. What I'm also looking at is the fact that this is a triangle from here to here to here. And if I know that this is 48 and this is 45, and part of this is 27, all I have to do is find this missing value here. So what we're going to do is 48 plus 45 is 93. So we know that's 93 degrees. If the sum of the angles in a triangle is 180, okay, then what I have to do next is just subtract. So I'm going to go 180 minus 93. And what I have now is 787. And that means that this plus this is 87 degrees. I'm going to subtract 27 and I get 60. So this angle here is 60 degrees. So that's ADB, which is 60 degrees. We found BC, which was 54 degrees, and we know BAD, arc BAD is 190. Suppose the diameter of a circle is 26 centimeters long. So if it's a diameter, it does go through the center. It going through the center, it has 13 and 13. A chord is 24 centimeters long. Now, again, remember when we were talking in the other video about chords, remember, you want your chords to actually touch something. So by me putting my chord, which is way over here, this is not easy to solve. This is not helpful for me to solve this problem. So what I'm going to do is I'm actually going to draw my chord again, but I'm going to draw my chord that is 24 centimeters long, and that means it's pretty big, here, and I'm going to attach it to that. So that's 24, meaning that anytime my center comes down like this, that makes that perpendicular. It means that that's 13, that's 13. If this whole length is 24, this is 12, and this is 12. And this being a right triangle, that makes that a 5, 12, 13 triangle. Find the distance from the center. Well, the distance from the center is 5. For this triangle, for this circle, we know that AB is tangent. Well, if it's tangent, then that means that that's perpendicular. We know that AD up here and AE are secants. So our job is to find all these values. Well, to find the first value, which is AC, which is this length from here to here, Remember, all radii are congruent, which means that's 10, and so is that. So that means that that's 10 plus 16, which is 26. Excuse me. AB, I want to find this next. So I know that this is a right triangle, and so I can do 10 squared plus 26 squared is equal to, oh, that's not right. Hold on. That means that, because this is my hypotenuse right here, 26 is my hypotenuse, so that's what you set it equal to. So 10 squared plus x squared is equal to 26 squared. So we have 100 plus x squared is equal to 26 squared, whatever 26 times 26 is. X squared is equal to 26 squared minus 100. X equals the square root of 26 minus 100. So in this case, for AB squared 24 is going to be, X is going to equal 24. Okay. And yes, I did work that out first. Okay, so we know that X is 24. Okay, so then we have, let me erase this little circle here. Then we have, this being 10, I want to find the measure of DAE. So I want to find this arc, right? This angle right here. So what I need to do from that is I need to go this arc here minus this arc here, divide that by 2, and I get this angle, okay? But I don't have this arc. But I do know that this is a diameter, and then this all the way around here is 180 degrees. So 90 plus 60 is 150 degrees, which means what's left is 30. So in order to find this problem here, I'm going to go, for this one, I'm going to go to find the measure of angle DAE. You're going to say 60 minus 30 and divided by 2. And that's going to be 30 divided by 2, which is 15 degrees. And lastly, so this is 15. I'm trying to find FE, which is this chord right here. Okay, so in order to find that chord, I'm going to erase some of this stuff on here so that I can see what I'm doing. So in order to do that, okay, what realistically I'm seeing is, this is what I'm looking at. I've got this length here, and then I've got this right here, all right? And what you know is that that's 10. Okay, and that's 10. All right, so remember when we were working on our chord, we were doing a chords part, and then we said if we had 2 secants, okay, there's our 2 secants. It's the outside times the sum is equal to the outside times the sum. Okay, so that's what I'm looking at. I'm going to put these new values. I've got the outside is 16, and the outside here is 18. The sum, or well, from here to here is 20. And from here to here, that's what we don't know. Okay, so, and see, 16 goes with 20, and then 18 goes with, I don't know. And so what we're going to do is you go the outside, so 16 times the sum, which is 36, is equal to 18 times the sum being x plus 18. So for this problem, you've got 16 times 36 is equal to distribute 18x plus 18 squared. Your job is to find x. So you've got 18x is equal to 16 times 36 minus 18 squared. You're going to take all those numbers, and for this problem right here, solve for x. X turns out to be, I think it's 14. Yeah, 14. And so x turns out to be 14. And you're just going to go, you can use your calculator, 16 times 36, get that number, subtract 18 squared, get an answer, divide by 18. And then you're going to get 14 as your answer. The next problem, these 3 problems are all dealing with our segments. And again, we had the same shapes for segments and the same shapes for angles, but one's obviously asking for angles and one's for segments. This is for segments. So when you have the tangent and the secant, you're going to go 8 squared is equal to 8 times 8 is equal to the outside times the sum. So it's going to be x times x plus 12. So in this answer, you've got 64 is equal to x squared plus 12x. What you need to understand about this problem is that it's quadratic, and you need to set it equal to 0. So you've got 0 equals x squared plus 12x minus 64. And you need to decide what times what is going to give you 64. So you're going to have to work that out. Let's see here. We've got 0 is equal to x plus something and x minus something. So in order to work this out, we need to figure out all of our factors of 64. So let's work that out. So what I would use for this problem right here is probably 12 times, I would go 64 divided by 4. 64 divided by 4 is going to be 16, and 16 minus 4 is going to be 12. So that's what I would use. And so we're going to do that, and we're going to say it's positive 16 because you're trying to make a 12 here. So we're going to say positive 16 times negative 4 is going to be 12. However, when I split this up and I set them both equal to 0, I get x minus 4 is equal to 0, and I get x plus 16 equals 0. I get x equals 4, and I get x equals negative 16. Well, you can't have a negative length for a side. So therefore, for that segment, it's not accurate. It doesn't work. It's no solution for that. This answer is 4. So when you're writing your solution sets, you're going to go x is equal to 4. And then you're going to put 16, negative 16 on the outside, because that tells me that that answer is extraneous, which basically means that it's a solution, but it doesn't work. It's an answer, but not a solution. It doesn't work when I plug it in. This length cannot be a negative value. You're not going to measure something and go, oh, negative 16 inches. We're not going to do that. So for this problem right here, again, outside times the whole length. So we're going to go 6 times the whole length, which is x plus 6, equals 5 times the whole length, which is 5 plus 7, which is 12. So then we have, let's see here, distribute, or actually we could distribute, yes, but I also could divide. And I'm going to divide by 6 on both sides. So I have on the left, x plus 6 equals 6 divides into 12 twice. So 5 times 2 is 10. I'm going to subtract 6. I get x is equal to 4. And 4 is fine to have as a length. Okay, for this one, these are the segments that are inside. So this one's just x times 4. It's not times a sum. It's just segment times segment. So it's going to be 4 times x equals 4 times 10. And so I'm going to divide by 4 on both sides, so I get x equals 10. So for this group of problems, we have to be able to subtract, of course, because we're going to be going, this is the secant, 2 secants, this is a secant with a tangent, and these are 2 chords. So for this one, to find angle x, the measure of x, we're going to go 95 minus 25 divided by 2. So that's going to be 75, or actually 70. So x is equal to 70 divided by 2. So x is equal to 35 degrees. For this one, we're going to again subtract, but the angle right here, 20, is equal to x minus 45 divided by 2. For this problem, we're going to cross multiply, and we get 40 is equal to x minus 45. I'm going to add 45 to both sides, and I get x equals 85. And for this one, because the chords are inside, I'm going to add. See, when my angle that I'm trying to find is outside, you subtract. But if the angle that I'm usually trying to find, which is formed by 2 chords, is inside, then I have to add. So you're going to go 80 plus x divided by 2 is equal to 70. We're going to cross multiply, and we're going to get 80 plus x is equal to 140. I'm going to subtract 80 from both sides, and I'm going to get x is equal to 60 degrees for my outside. Oh, and by the way, x, that was also a degree. A few more for this one. Now, this one, you think, oh, I'm going to do all these really crazy things. I'm going to do this, and then I'm going to have to do other stuff. But actually, the theorem states that this is our ice cream cone theorem, in case you forgot. This one states that if you have a point out here and you have two tangents that intersect in a point, those segments are congruent. So for this one, x is just equal to 14. For this problem, I know this is similar to one I just did on the previous page, but we didn't do one with the variable outside. We did one with the variable inside. So let's do that. That's just x squared is equal to 3 times the sum, which is 5 plus 3, which is 8. So we have x squared is equal to 24. We're going to square root both sides, and I get x equals the square root of 4 times the square root of 6. So x is equal to 2 root 6. For this one, I am going to see this is a radius, which happens to be the same length as that radius, which is 5. And this looks like a 5, 12, 13 special right triangle. And therefore, x plus 5 is 13. So x must equal 8. Okay, cool. So that's all I have for you for today. So thanks for watching, and I hope that helped.